our third session. I apologize for the mistake in the entry uh, video where it was written session 2. It is actually session 3. Actually, technically speaking, it is a continuation of session 2 only. We are yet to finish the chapter. So, let us begin with our class today and let us open our book. All of you, please open up your books and let us go straight to page number. And you can see my book is opening in quite a stylish way actually. To wait for my book to load. Yes, yesterday we had finished with computer language on page number 1, and today we are going to be beginning with computer languages. Today we are going to be beginning with page number 2, and that is low level language. Yesterday we had discussed that computers need to be taught instructions with the help in the process that is known as programming, and computers need to be explained how to go about doing certain things. Now, the language in which you talk to the computer is known as programming language, and there are various kinds of language. Today we are going to be talking about different kinds of language. So let us begin with low level language. A low level language is a language of the computer and is therefore directly understood by the computer. The low level language is actually the language which talks to the computer directly. What is indirectly? Wait, we'll talk about it as and when we go down the chapter. So, what is low? Just understand for the time being, just understand this, that a low level language is a language that talks directly to the hardware of the computer. It is designed in such a way that it can operate and handle the entire hardware component. A low level language, as low level languages are closer to the hardware and components, programs written in low level languages usually do not require any translation or interpretation like high level languages during execution. So, high level languages require an interpreter to talk to the computer, while low level languages can directly talk to the computer. Now, machine language and assembly language are the popular examples of low level language. You know, there are two types of low level. There are other types of also, but two of the most popular ones are the machine language and assembly level language. Right? Now, if we just go down, we go and pay attention to this small box in the corner. Low level languages directly interact with the hardware without conversion or very little conversion. Low level languages basically directly interact with the hardware of the computer. Okay, just understand this. We'll understand it more elaborately as and when we go down the chapter. Alright, now what are the two types of low level languages that we have studied? We have talked about that they are machine language and assembly language. So let us start with machine language, and there it is in front of you. Machine language is a low level language where a set of instructions is given in the form of binary or hexadecimal. Hexadecimal numbers to which the computer responds directly. Every set of instructions is a group of binary 0 or 1, 1 or 0, 1 and 0, interpreted directly by the central processing unit. For a given machine language, each unique combination of ones and zeros in an instruction has a unique interpretation. These instructions may vary with different kinds of hardware and therefore difficult to write and manage. For example, instructions given for a particular machine to perform a task may be completely different from the set of instructions to perform the same task on some other machines. Now, if you look at the small image that is given here on the screen, figure number 1.4, you see this operator or the user of this machine is typing in only 0 and 1, and you see on a screen there are combinations of 0 1 1 0 0 1 1 1 0 0 0 1 1. This is the machine language. It talks directly to the computer. Okay, these are codes. Okay, combination of 0 and 1. How do you write them? Do you write them as 1 0 or do you write them as 0, 1? Do you write them as 1, 1, 0, or you write them as 0, 0, 1? These are different types of codes that a machine understands. Alright, and you have to tell the machine in these codes only. The machine understands these codes only. These codes are known as binary codes. Okay, they are in the form of 0 and 1, the basic units of computer language. Now the CPU understands this. Now the codes for a particular hardware are unique. What does it mean? It means that the codes that you have written for one printer, suppose you are writing codes for one printer, may not be applicable on another printer. They are different codes. This printer is different, this printer is different. Alright? Therefore, it is very difficult to remember all the codes of all the hardware. There are thousands of hardwares in this world. You very well know about it. So imagine if you have to remember every single hardware code. Very difficult, right? Machine language is a little difficult. Okay? So when machine language was the initial language it was started, and then the computer scientists found it very, very difficult. So they came up with a small change. Okay? And they converted a small change. And what is that change? They developed what is known as, okay, we will talk about the machine language a little bit more. On page number 3 for me. Alright. The following example shows how a light bulb is controlled by a processor executing machine language program in main memory. The controller has the ability to switch on or off the light bulb. It can even brighten or dim the bulb, but not beyond fully on or fully off. Each machine instructions are 1 byte, 8 bits and 8 bits long, and corresponds to the following operations of the processor. Now, if you pay attention to the small table that is given here, now see what is written here. It is written, these are 8 in number. 8 zeros equals to stop program. 7 zeros and 1 switch on the bulb. 6 zeros, single digit 1 and another 0 is switch off the bulb. Alright. 5 zeros, single digit 1 and 2 zeros is dim the bulb by 10%. Alright. And so on and so forth. These are the what you see is machine under the machine instruction table. What you see under the machine instruction table, these are codes. When you tell the computer these codes, the computer does what is known as operation in the, if you see them, they are written in the machine operation section of the table. Now, when you enter this code, the machine will do this. When you enter that code, the machine will do that. So there are different kinds of codes for the computer to follow. As you can see in the above example, each machine code performs a certain operation. But it is difficult for humans like us to remember each of these instructions. Moreover, these instructions may even vary with different processors. Now, as I said, these are very difficult to remember. 0, 0, 1, 1, 0. Okay, how many zeros, how many ones? Very difficult for us humans to remember. Also, they may be different for different hardwares. So, won't that be too much of a difficult? Then computer will not be something that will be helping us, but it will become a pain for us. Okay. The major advantage of using a machine language program is its speed. It executes very fast, as the computer directly understands the instructions. The disadvantage of using a machine language program is it's difficult to understand and develop a program. Moreover, it is difficult to find errors and modify it. Alright. Now, machine language, why do people use it? Why? Because it is instant. You put it on, the machine comes on. You put it off, the machine goes off. In higher level languages, you give a code, the machine will change it, interpret it, and then tell the hardware. So there is a small, very tiny time lag, which that is not there in the machine language. Machine language is very, very quick. Alright. So machine language is very, very quick. But the problem with machine language, as I said, it is very difficult to operate a machine in machine language. There's lots and lots of codes to remember and to find a problem. If you have given wrong instructions, you want to correct those instructions, they will be very, very difficult. Why? Because if you look at the screen of a machine language, it is only a combination of 0 and 1. You need to go by every digit to confirm what is the mistake that you have made. Alright, so machine language becomes very difficult to handle. Now what are the examples of machine language? Now if you look at this table, example of machine language, here's what a program fragment looks like. Look at the screen. What does it say? 101, 0001, 10. There is a huge combination. And what does it mean? It means Z equals to X plus Y. Only to write this small Z equals to X plus Y, we have to put so many codes. If you pay attention to the screen, how many codes are there? We have got 1, 2, 3, 4. 4 codes in each column. 1, 2, 3, 4. And how many columns do we have? We have got 1, 2, 3, 4 columns. That means 16 codes. 16 bytes of codes. For what? What are we writing? We are only writing Z equals to X plus Y. For this very small thing, we have to write 16 bytes of code. Imagine what would we have to do if we have to do something very, very big. Very difficult. Very difficult. Now, to come up to sort out this problem, as I said earlier, the computer scientists came up with a very unique step that is known as the assembly language. Now, the assembly language, let us go through the assembly language. Machine language programs were difficult to write and manage, and therefore scientists created another language called the assembly language or an assembler language, which has comparatively easier which was comparatively easier to program with. Okay, here instructions were given in the form of mnemonic codes. All right, now new words, mnemonic codes. Now, as we have studied so far, machine language were very difficult. So the scientists came up with a little bit simpler, not very, very simple as yet, but still it was a little bit better than machine language that was known as the assembly language or assembler language. Now here we replaced the 0 and 1s with a new set of codes, and they were known as mnemonic codes. Okay, now we will read about what are mnemonic codes. Now what is a mnemonic code? For example, to add, just a second, let my page turn about. Okay, now in mnemonic codes, to add two numbers, the mnemonic add is used and to subtract sub is used. Looks quite simple, right? Just like in mathematics, add for addition and adding a particular set of numbers, and sub for subtracting. Because of this assembly language program, this is called symbolic machine code. Okay, because they were symbols used for operation. For addition, add was the symbol. For subtraction, sub was the symbol. Each instruction given to the computer corresponds to the computer's architecture. Thus, learning the assembly language of one computer may teach you something about assembly language programming. But the programs will not execute in another make of computer, as each of mnemonic codes has one-to-one correspondence with equivalent machine instructions. Now, remember, mnemonic codes were a little higher than the machine codes. Alright, they were a little higher than the machine codes. That means that mnemonic codes were to understand or was a little simplified version of the machine code. But remember, machine codes were particular for every hardware. Therefore, even mnemonic codes were particular for that particular hardware. In order to operate machines, you had to remember, even mnemonic codes, you have to remember different mnemonic codes for different hardwares. Okay, it was simpler but not as simple yet. Okay, the following sample program shows a sample assembly language program for a personal computer that is used to display hello world on the screen. Now, if you look at the table on the side, which says to say hello world, what do? You have to give these codes. Code segment assume CS code, DS code, origin 100, H, start, move, H9, blah 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 blah. These are all codes just to write the word hello world. Alright, this was the assembly language. Again, not that simple. It is the computer screen will look like this, but it will not be that simple. It is better than the 0 and 1 of the machine language, but it is still a little difficult for people to understand. So perhaps the above code is better than the machine code language, as it does not have a set of binary strings to represent the instructions. Rather has mnemonic codes like MOV, INT, DB to represent the instructions. Now, these were instructions codes, small codes to tell the computer to do something. It is better than the 0 and 1 that that were there in the machine language. But even assembly language programs are difficult to understand because of the cumbersome syntax, even by good programmers. There are lots of syntax, lots of codes that you have to remember for every single execution of program. It is very difficult for a programmer to remember all the codes because there are so many hardwares, and all hardwares have got different coding system. Moreover, since it is not directly understood by the machine, it requires an assembler to translate program to machine language for the computer to understand. Now remember, I said computer will only understand machine language. You can talk in assembly language. What you will need is an assembler. What is an assembler? What you talk in assembly language, it goes to an assembler. It converts it to machine language. It tells the hardware. Whatever returns the hardware gives comes back to the assembler. It is again reconverted and sent back to you. Just like suppose if you were to go to a place where you do not know the local language, what would you do? You would need what is known as a translator. Just consider the assembler to be the translator between assembly language and machine language. Okay, you will need an assembler. So it is a little bit slower than the machine language because machine language is very quick. You just give the code, machine does it. But here you give it to the assembly mnemonic codes, it goes to the assembler, it converts, it goes to the machine language, and then whatever is executed, again it is converted, come back to the assembler, and so on and so forth. Now, let us proceed forward. Now, a small quick fact in front of you. Assembly language programs are not directly understood by the computer, but requires conversion to machine language using a translator called the assembler. We have already discussed this. Before I continue, I had told you at the beginning of the class yesterday also, and I'll tell you again, keep a notebook with you. If you do not understand something in your book, underline it. And if you want to ask something else about the chapter, just note it down on a notebook and you can send it to me through a message. Remember to send me messages about what is discussed in the class. There are lots of things you may have queries about, and it is good. You want to know about certain things, but it would be better if we keep our discussion to the right place rather than going here and there. Now, so any doubts, note it down and send it to me later on in the comment section. Now, let us look at what are the advantages and disadvantages of assembly language. Advantage: it is easier to write a program in assembly language compared to the machine language. Well, machine languages were just 0 and 1. Alright. Here it is a little better. So if I am adding, I can give a code that is add. If I am subtracting or move or come or go, we know we have small codes that we need to remember. It is a little easier than just writing 0 0 1 1 1 0 0 etc etc etc. Okay. This is because instead of using string or binary digits, it is written in the form of symbolic instructions. What is the disadvantage of assembly language? Since assembly language is specific to a particular machine architecture, a program written for one processor will not work for a different processor. It is architecturally different. Different machines, different codes. Therefore, still a lot of problem. Now, assembly language programs are not as fast as machine language. Again, assembly language is not very fast. Remember, mnemonic codes, assembler, machine language. Machine, machine, machine language, back to assembler, then back to mnemonic codes. Okay, so it is a little slower. Okay, it is difficult to find errors and modify an assembly language program also. It is also difficult to find out errors. Why? Because there are so many codes, so many codes. You will get confused. Oh, Baba, what should I do? ঠিক আছে? Now, if you look at a small box here, what does it say? Just give me a moment. It says low level languages are difficult to learn and master compared to high level languages. They are difficult, not impossible. Those people who are really good at computers, they can do it. It is not impossible. It is devised by human beings. So of course there are people who can do it. It is difficult. Okay, I would say the word difficult is the most important thing. It's very difficult to master. So those people, those of you who want to become computer engineers and you are really good at it, you can give it a shot. Try learning the assembly language and the machine language. Okay, now our next section is about high level languages. Now let us proceed to high level languages on page number 5. Just give me a moment. High level languages. The demand for more complex programs and programming methodologies made scientists develop programming languages which started being more like human spoken languages and structured. These languages are called high level languages. These languages are easier to understand and write and therefore gain tremendous popularity. High level languages allow programmers to concentrate on the logic of the problem to be solved rather than the intricacies of machine architecture such as required in the low level languages. This is because the high level languages are independent of the underlying hardware architecture. Examples of high level languages are C, C++, Java, Python, QBasic, Logo, etc. The high level language QBasic will be covered later in the book. Alright, if you just go to the small section in the corner, sorry. Now, if you look at the small box in the corner, high level languages are like natural languages, especially English, and is therefore easier to learn and master. Now, because low level languages were very difficult to understand, whether it is the assembly language to mnemonic codes or the binary digits of machine language, the computer scientists decided to make it more and more simpler. Also, there's another problem with the machine language, and that was that their coding was particular for every hardware. That means every different hardwares had different kinds of codes. That is why the computer scientists all over the world worked tirelessly and came together with a new idea and new plan of high level languages. These level languages were more like the language that we speak, like English. Alright, you give the code to a computer in simpler English. It is not that simple English that we speak or converse in, but still it was closer to English. Alright, and the commands were easier to give. Last but not the least, the high level languages had the advantage, and the advantage was that you could use the same code on different hardwares also. So high level languages are a little better version of computer languages. Now some of the examples are already given here: C++, Java, Python, etc. Now if you look at the three icons that are there on the screen, okay, C++, Java, Python. The following example shows a sample program written in QBasic to accept two numbers from the user and display their sum. Now you want the computer to add two numbers. All right. How do you make the computer do that? Okay. Now in QBasic is a type of computer language. What do? You enter two numbers A B, C equals to A plus B, print sum equals to C, N. Now this is a code. Remember, this is not what it looks like. This is a code which you tell the computer to do. Alright. Now this is the kind of code that you tell the computer to do. Now if you see, the codes are in rather simpler English. Input, enter, numbers, these are English words. Print, okay, these are English words. So the computer language is more simpler to understand. The above program now looks simpler and closer to humans and is therefore easy to understand. For example, the first line, input, enter two numbers A, B, is used to accept two numbers from the user into A and B. This is then added up and stored in C using the statement C equals to A plus B. Now, this is more simpler English for us to understand rather than the mnemonic codes or the 0 and 1 of the machine language. The next line then displays an added result on the screen using statement print sum C. The last line is used to mark the end of the program. Thus, you can see that the instructions correspond to natural languages like the English that we speak, making it easier to learn. However, a translator is required to convert the program written in high-level languages to machine language for the computer to understand. Remember, again and again, the computer does not understand Hindi, English, Bangla, Punjabi, Urdu. It understands 0 and 1. Now, whatever language you want to give the code in, you have to convert it for the machine. Alright? Like in the assembly language, you needed an assembler. In high-level languages, you need a translator program. It is a different kind of program that translates whatever command you give into machine language. What is the advantage of high-level language? Programs written in high-level languages are comparatively more readable than the low-level language. You can at least read them and understand, okay, this is what is going to happen. In low-level languages, it's very difficult to read and understand what is going on. Okay? Now, programs written in high-level languages can run in different machine architectures with little or no change. The programs in high-level languages, one of the advantages is that it can work on different hardwares also. Okay? Now, if you look at a small box given here of quick fact, the high-level language HLL designed for computers, the first high-level language that was designed for computers was known as the Plancol, created by Konrad Zuse, but was never implemented because of the Second World War. This man had developed a high-level language, but unfortunately the world went into Second World War and his high-level language could not be implemented all over the world. It was the Fortran which was the first high-level language designed by IBM for its PC. Fortran was the first. It's a general knowledge trivia. The first high-level languages of the world being implemented. Remember, one that was what developed was Plancol, but Plancolcul. Okay, Plancolcul. All right, but it could not be implemented, and Fortran was the first high-level language implemented by a company called IBM, International Business Machines, for its PC. Alright, so that was the small general knowledge trivia about high-level language. Now let us turn to our next page. Next advantage of high-level language, it is easily possible to remove errors in a program. That is easy debugging. when you make a mistake in giving instructions. Suppose you were teaching somebody to do Maggie, to make Maggie. Okay, what do? All the steps. Suppose by mistake you say add sugar. When the Maggie is made, you taste Maggie and you say, "Arey, this is tasting sweet." So you go back and find out what was the mistake that was done. The mistake was you added an extra step called add sugar. So you correct it. Okay, you ensure that the next time the add sugar is not there. All right. So that correction of programming is known as debugging. What is it called? Debugging. If you look at this first line and the last word of the first line on page number 6, all right, it is known as debugging. The word bug means a mistake in programming. When you have made a mistake in programming, you told the computer the wrong command. So the computer did the wrong command and you realize, why is my computer doing something wrong? So you go and find out what mistake did I do, because the computer cannot do a mistake. It did what you told it to. So you have to find out what mistake did the programming did, and the mistake is known as bug, bug, and to rectify a mistake in computer language, computer programming is known as debugging. All right. And because the high level languages are easier to read, you can easily find out where was the mistake. Okay, because you just read, okay, this does not make sense. When you're reading an English line, you say, okay, this is not right. So you can easily find out the mistakes. Next, it is easily possible to master high level languages as instructions corresponds to natural languages, and therefore software can easily be developed. Now it is easier for people to understand high level languages also. Okay, because it's more closer to other language that we speak. So people understand it very, very easily. What is a disadvantage? First, it requires a translator program to convert a program written in high-level language to the machine language. Remember, translator, you will give your command in English and whatsoever. It will go to the translator. It is converted into 0 and 1, 1 and 0, and combinations of that. It is given to a computer, and then the computer works. So the process goes via a translator. It cannot go directly to the computer. No. That is one of the disadvantages. Number 2, it does not execute on the computer directly. Because it goes via the translator, the high level languages does not work directly on the computer. No. And therefore, it can be sometimes slow also. Now, what is the difference between high level languages? The last thing that we are going to be talking about today is the difference between high level language and low level language. We'll go very, very fast. Number 1, learning. It is easy to learn a high level language. Of course, it's in simple English. But low level language? No, it is difficult to learn a low level language. High level language understanding. As high level languages are almost like natural languages, it is easier to understand. Low level languages are difficult to understand because they are written either in mnemonic codes or bits and bytes. Number 3, execution. Now, this is where low-level languages are a little better. Why? Programs in high-level languages are slower in execution because they have to go via a translator. While execution in low-level languages may be a little quicker because, as you know, machine language is 0 and 1. It talks directly to the computer. Modification. It is easier to modify or update programs in high level languages because you can find out, read your errors, but it is very difficult to modify because all the codes look the same. They are just combinations of 0 and 1. Now you have to very patiently look at every single code to understand, okay, I think I added 2 extra zeros, or I did not add 1 0. Okay, and to find that 1 extra 0 in so many zeros and ones, very difficult. Facility at hardware level. High level languages do not provide much facility at hardware level compared to low level languages. Facility at hardware level for low level languages provide facility to provide programs at hardware level. Now, low level languages talk directly to the hardware, so they are very, very quick and easier. They communicate directly with the hardware. But high level languages do not do that. So it is a little bit difficult. You have to make small adjustments for hardware. Knowledge of the hardware. High level languages are built in such a way that there hardly any knowledge of the hardware is required for the program. Now, knowledge of hardware is very necessary to have to write your programs in low level languages. Remember, I said low level languages talk directly to the computer. Okay, they talk directly to the computer, so you must know what is the hardware. But high level languages are adaptable, they can change, so too much knowledge of hardware is not required. You can simply concentrate on what you want the computer to do. Last one, uses. What is the use? It is what the high level language is. It is usually used to write application program, while low-level languages is usually used to write programs related directly to the hardware manipulation. Now, when you have to make a software which is for general purpose, which can go run on almost all machines, you can use a high-level language. But when you have to write a particular software for a particular hardware, specifically for a particular hardware, you have to use machine language. Okay, so that was high-level language and low-level languages. With that, we come to the end of today's discussion session.